By using the dot products, we can find the angles between two vectors. For example, here we have two vectors v and w. Vector v can be rewritten as 3, 1, minus 4. Here, 3, 1, minus 4 are coefficients of vector I, j, and k. You remember that vector I is the vector 1, 0, 0. The unit vector direction points to the direction of the x-axis. J is the vector 0, 1, 0, and k is the vector 0, 0, 1. So they correspond to the x-axis, y-axis, and z-axis. So these are vectors I, j, k, and that's why we can write down v either this form or this form. Similarly, vectors w is 1, 4, plus 2. And recall that the dot product of two vectors v dot w is the length of vector v, the length of v, times the length of w, times the cosine of the angle between them. Here theta is the angle between two vectors v and w, and the angle theta is between 0 and pi. So applied to our data, we have v dot w is 3 times 1 plus 1 times 4 plus minus 4 times 2. So we have 3, 4, 8, so minus 1. So the dot product of two vectors is minus 1. That is the left hand side. Now the right hand side is the length of v. So this is the left hand side, the right hand side. The length of v is given as, so here's our vector v and vector w. So vector v is 3, 1, minus 4, so the length of v is 3 square plus 1 square plus minus 4 square. Square root of 9, 1, 8, so square root of 18. You do similarly for w. The length of vector w is square root of 1 square, 4 square, 2 square. So square root of 1, 16, 4, so 21. Square root of 21. With that, we computed these two terms. Now we have cosine of the angle theta is cosine of the angle theta is the left hand side divided by this. So v dot w divided by the length of v times the length of w. So this is v dot w is minus 1. The length of v square root 18. The length of w square root 21. And then the angle theta is the arc cosine of these quantities. So that is how we compute the angle between two vectors. So here's the angle between two vectors v and w. And using the dot product, we can check if the angle between two vectors is acute, right angle, or obtuse. without even needing to compute the whole thing.